Hello and welcome to Algebra 2R Final Exam Review. This video is dedicated to what we did in Unit 3, which was rational equations and expressions. Alright, so starting from the top, very first thing we talked about with rational expressions is determining where they're undefined. Undefined is meaning that the denominator would equal 0. So in order to solve these problems, we simply set the denominator equal to 0 and solve. So I don't even care what the numerator is, completely ignore him. Set the denominator equal to 0. Looks like I can just factor this guy. So using my AM factoring techniques, I can factor this with a -3 and a -4. And get x equals 3 and x equals 4. And those are the values that would cause the denominator to go to 0, aka causing our function or expression to be undefined. When we multiply expressions, we factor everything first, and then we cancel one factor in the numerator with one in the denominator. And it can be anywhere in the expression or anywhere in the problem. So looking at the first guy here, I notice this is dots in the numerator. So 3 plus x, 3 minus x. Bottom is an AM factoring. Numerator of the second fraction, I can pull out a 4x. And looks like I can pull out another 4x. Okay, now once I have everything factored, I'm going to cancel, like I said. X minus 5 and x minus 5 will cancel, numerator and denominator. The 4 x's will cancel. And the x minus 3 with the 3 minus x will cancel. However, it will cancel or reduce to a -1, which is what this note is about over on the left. And we call those opposite factors with the subtraction. Okay, so at this point in the numerator, I have a -1 times 3 plus x. In the denominator, I have an x plus 4. And that's your final answer. Make sure you don't forget the parentheses in the numerator, or it would be equivalent to -3 minus x. So just be really careful there. Now, it's the same exact idea with division, with the exception of you got to do keep, change, flip first. So you got another dots going on. Some more AM factoring. Oops, that's supposed to be a 6. So again, I'm going to change this to multiplication and flip the second fraction. So this x squared minus 6x, I can factor an x out. Notice how I'm putting it in the numerator. AM factoring, x minus 6, x minus 6. Okay, now's the fun part, we cancel. X plus 6's, x minus 6. In fact, there's 2 pairs of x minus 6's, so that's nice. And then it looks like we're left with x over x minus 3. And then we're done. So you could leave it there with the parentheses, or if you lost the parentheses there, that's mathematically equivalent as well. I know my students will ask about that sometimes. All right, now what's super important when you add or subtract, which in my opinion is the harder thing to do here, is you have to have a common denominator. It's just like when you guys are in elementary school and you're adding 1/2 plus 1/3. You know you need a common denominator of, let's say, 6. So you'd multiply the top and bottom by whatever you need to create that common denominator. And then you can combine. It's the exact same idea with rational expressions, so with our polynomials. So this first guy already has a common denominator, so awesome. Just keep in mind that negative is going to distribute to each part of that second fraction in that numerator. So that is c plus 4 minus 2c minus 5 in the numerator, all over c minus 2. So this is c minus 2c, which is negative c. 4 minus 5 is negative 1. And then you're done. You can't cancel anything. You can't cancel the c's. You can only cancel or reduce across multiplication like what I modeled up here, because everything was factored to multiplication. It was good to go to cancel. So you're done. This guy needs a common denominator though. So if I look at the second fraction, I notice that this denominator is the same thing as h plus 4, h minus 4, which makes my decision pretty easy to get a common denominator of h plus 4 and h minus 4. So I'm going to multiply top and bottom of the second fraction by what I need in order to get a common denominator. Distribute that 2. Okay, now once you have a common denominator, just like what I modeled with the 3/6 and the 2/6, I can combine the denominators together to be one denominator, to be a single fraction. H plus 2h would be a 3h, and then negative 20 and a positive 8 would be a negative 12. Okay, so now at this step, I want to see if I can reduce. I see a GCF of 3, which means I can factor that out, which I'm just going to squeeze that in right above this. And what you guys are seeing is now at this point, I have an h minus 4 that's going to cancel with an h minus 4 or reduce, so that means my final answer is 3 over h plus 4. And then you're done. All right, now complex fractions can be taught in a multitude of ways. You could look it up online and get different resources, and you could get like probably 6 different ways to solve these. Now, based on what we teach in school at East, you have 2 ways to do it. So I'm going to go through those 2 ways with you guys, or at least the 2 most popular ways, I'll say. I'll start with the first way that me and Ms. Costanzo teach it, which is getting a common denominator among all your little fractions here. So I'm going to take this 1, put him over 1 to make him a fraction, and then I look at the denominators of 1, x, y, and y, and I decide on a common denominator among all of those. So I would say the common denominator would be x and y. With that being said, I'm going to go around to each of these little fractions and multiply by what I need to get a common denominator of x, y. So like this guy would need both of them. That guy would need a y, an x, and an x. So by doing that, I have xy over xy plus y over xy all over x cubed over xy minus x over xy. Once the denominators are the same, they would all end up canceling or reducing. And that would leave me with xy plus y in the numerator all over x cubed minus x. Now, just like what I did up above, I got to make sure I can, if I can, like reduce this, factor and cancel. So in the numerator, I can factor out a y. In the denominator, I can pull out an x. And I'm actually noticing I can even factor that further, so I'm just going to do it right below it. Okay, now in factoring that with dots, I notice that I can cancel an x plus 1 and an x plus 1, and that leaves me with y over x times x minus 1. So that method is getting common denominators among all the fractions. And canceling them out, and then solving the numerator and denominator. Now, the way that Mrs. Marin teaches it, and other teachers as well, is combining the numerator to one fraction, the denominator to one fraction, and then doing keep, change, flip. So with that being said, if you want to copy down this work, hit pause. Otherwise, I'm going to erase this so that I can do it in another way. Okay, so still going to put this over 1. That's the same between the two methods. Now, in the numerator, I would say the common denominator is x. So you could multiply top and bottom by x. And then the bottom actually already had a common denominator. So that makes this one particular problem actually pretty easy in that regard. So in the numerator, you would have x plus 1 all over your common denominator of x. And then in the bottom, you have x squared minus 1 all over the common denominator of y, because those combined nicely. Now, this is just really a big division problem. So this is the same thing as x plus 1 over x times y over x squared minus 1. Just like what I showed in the previous method, x plus 1, x minus 1 will factor with that x squared minus 1. Okay, now it's just a multiplication problem. I see the x plus 1's cancel, and that leaves me with y over x times x minus 1. Okay, so again, I don't have anything filled in here because ultimately it's however your teacher taught you, but that's a couple ways to solve complex fractions. What I will write here, though, is get common denominators. I feel like between those two methods, that's a pretty universal thing that we're doing, whether it's throughout the entire problem or just in the numerator and denominator. All right, moving on to the next page. Fractional equations. If it's a proportion, we will just cross multiply. Otherwise, we will make a common denominator across both sides of the equal sign, drop the denominators, and then solve. Okay, now you got to make sure when you're solving these that we check our answers because we don't want anything to go undefined. Okay, so that's what this is coming from. It's step 5, so just be aware. All right, so first guy, I have a proportion. It's a single fraction equal to a single fraction, so I'm simply going to cross multiply. So that's 2b times b plus 1 equals 2b minus 3 times b plus 4. I'm going to make this slightly smaller so that I have a little bit more room for the next problem. Great. Okay. So this would be 2b squared plus 2b. And then I'm foiling over here. Now this problem's kind of nice because the 2b squareds will drop out on either side. So that leaves me with a 2b equals 5b minus 12. Subtract the 5b, and that would leave me with a negative 3b equals negative 12. Therefore, b would equal positive 4. Now, I just go back and check. Would that positive 4, if I look in the denominators, cause any denominators to go to 0? No, it wouldn't. So you're good to go. You don't have to reject anything. Okay, next example is not a proportion, so I'm going to get common denominators. Put that 3 over 1. Now, I would say between the 2, the 1, and the x, my common denominator would be a 2x. So I'm going to multiply first fraction by 2, so top and bottom. Second guy is going to need a 2x, and the last guy is going to need an x. Now, once you've figured out what you'd have to multiply everything by, this equal sign is your green light to ignore these denominators and then solve the numerator. So in the numerator, I have 2 times 1 plus 3 times 2x equals 7 times x. So 2 plus 6x equals 7x. So 2 equals x. So again, go back to the original problem. is this x equal 2 going to cause any denominator to go to 0? And that answer would be, no, it won't. So you don't reject it. Okay, gradually getting more complicated. Now I have some binomial denominators. First thing I'm noticing is this is the same thing as x plus 8, x minus 8. And that makes it easy for me to figure out that the common denominator between all three of these fractions would be one of each of those factors, x plus 8 and x minus 8. So this is my common denominator. That means that this fraction is going to need an x minus 8. The last guy is going to need an x plus 8. Again, top and bottom here. He has the common denominator, so he's good. Now, once you've figured out how to manipulate or adjust all those numerators, that's your green light, because it's an equation that I can now ignore the denominators and solve the numerators. So I have x times x minus 8 plus 16 equals 1 times x plus 8. Okay, so I'm going to subtract my x and get a 9x, or negative 9x plus 8. Do a little factoring. And t-chart it up. Nothing crazy, all Algebra 1 skills there. Now at this point, you got two solutions. Go back to the original problem. So again, you're looking here, okay? Do you have an issue with either one of these? You should. This x equals 8 is going to cause this denominator to go to 0, as well as this denominator. So therefore, you reject the x equals 8, and x equals 1 would be your answer. Now, it's possible that you have scenarios where maybe you reject none of them. Maybe you reject both of them. Maybe you have no solution. So just always make sure you go back and check, okay? Something else I want to emphasize, guys, what I'm doing right here is not the same thing as what I did on the previous page. The previous page had expressions. These are expressions, meaning they don't drop denominators. So I'm actually going to add a note here. Don't just drop your denominators. Because sometimes students will confuse this with what I'm doing on the equation solving part. So please be aware of that. Do not drop your denominators when you're just adding or subtracting fractions. It's only when we're solving equations like these three examples that you can ignore the denominators. Okay. We also put some radical equations in this unit. So in order to solve radical equations, you want to isolate the radical first, and then square, cube both sides, whatever the inverse is of what you got. And then again, make sure you check your solutions. So this first example here, I already have the radical alone. So I'm going to square both sides. The square will undo the radical. And then the right, when in doubt, write it out. That's a FOIL. So this is going to be x squared minus 8x plus 16 equals x minus 2. Subtract the x. Add the 2. So, factors of 18 that sum to negative 9, so negative 6 and negative 3. So I'm getting two solutions of x equals 6 and x equals 3. Now, let's check if that makes sense. So go back to your original. Radical x minus 2 equals x minus 4. If I plug in a 6, does that equal 6 minus 4? This would be the same thing as radical 4, which is 2, which matches the other side, so we're good. What about the 3? This would be the same thing as radical 3 minus 2. Does that equal 3 minus 4? So, this would give me the square root of 1, which is a positive 1. This would be negative 1. Those are not equal. Therefore, we would reject 3 as a solution, and x equals 6 would be your answer. Now, that's an algebraic check. Let's say a question like this was even just like a multiple choice. You technically could solve this all in your calculator by using the fact that you could set the left side of the equation equal to y1, the right side equal to y2, and finding the intersection. So let me show you what that looks like. So this would also constitute a graphic check of your solution. So for y1, I'm going to plug in the square root of x minus 1. For y2, I'm going to plug in x minus 4. And then I'm going to do a zoom 6 just to reset my window. Zoom 6 is your quick fix. There's your square root function. Here comes x minus 4. So this is a nice quick way of me verifying that the 3 rejected because you're not seeing the intersection at x equals 3. The intersection is at x equals 4. And you can even verify that in your table of values. At x equals 4, or excuse me, oh man, I kept saying 4. 6 I meant. Uh-oh. That's awkward. Hold on. That should be a 2. The funny thing is I was only off slightly. Alright, so now this will work. Okay, there you go. There's your intersection. Check it in your table. There you go. X equals 6 has a repeated y value of 2. I knew I solved it right. I just typed it in the calculator wrong. Whoopsie. Alright, hopefully that is okay and you get the idea. Alright, solving the cube root problem. Notice that it's not alone. You got to subtract the 8 first. So cube root of 5x minus 3 equals negative 2. And then for this, I would cube both sides. Add the 3 over. So I'm getting x to be negative 1. And then again, you could even use your calculator to do a nice little check of that to make sure your answer works. I can take negative 1 and store him as x, and then literally type in this expression. I want the cube root of 5x minus 3 plus 8. And that equals 6, which is exactly what I was hoping for. All right, extra problems that we talked about. Working together problems. Suppose that Jeff can paint a fence in 6 hours. If Tim helps him paint the fence, they can do it in 4 hours. How long would it take for Tim to paint the fence by himself? So our working together problems, I like to list out my info. I've got Tim, Jeff, and when they work together. So rereading this, Jeff can paint the fence in 6 hours. When we do these working together problems, it's always one job over the amount of time it takes. So 1 over 6. Together, it took them 4 hours. So together, I'm going to write as 1 over 4. One job completed in 4 hours. I don't know Tim, so let's call him 1 over x. Tim plus Jeff equals together, right? So this is 1 over x plus 1 over 6 equals 1 over 4. And now we're at a rational equation like what we did previously. But obviously, it was a word problem you needed to know how to set up. So between all of these, I would say my common denominator could be 12x, which means this guy would need a 12. Second guy would need a 2x. And the last guy would need a 3x. Now again, this is your green light that once you've figured out the numerators, you can ignore the denominators and solve the numerators. So this is 12 plus 2x equals 3x. So 12 equals x. So Tim is kind of slow. It takes twice as long as Jeff. All right, last problem, a more complicated radical equation because you're actually noticing that I have 2 radicals. Now, if you think back to what I wrote on the previous page about isolating the radical, well, if you have 2 radicals, what do? Well, just pick one of them to isolate first. So I am going to subtract this guy to isolate the x plus 3. So technically either one would work. I'm just picking one of them and I'm going to isolate. I'm now going to square both sides. That will undo this radical and give you an x plus 3. And then on the right, you're going to have to FOIL. So when in doubt, write it out. So this would be 9 minus 3 radical x minus 3 radical x, and then plus radical x times radical x is radical x squared, or just x. Any square root times himself is just the radicand back. On the left, we still have the x plus 3. Clean this up a little bit. I can combine those radical x's. Okay, and now you'll notice I have one radical in the problem. Let's try to isolate him now. Okay, so I am going to subtract the 9 and subtract the x. So you'll notice here that my x's drop out. That's kind of nice. And I'm left with negative 6 equals negative 6 radical x. I can then divide by negative 6 and get a positive 1. And then if you square both sides, we get x equals 1. Now, again, for a more complicated problem like this, especially if it's a multiple choice, you really could just plug it in your calculator and see the intersections. For an algebraic solution, this is 100% what you need to show. No matter what, I'm going to go ahead and check my work, though, because I want to make sure I get it right. So I'm going to plug the left side of the equation in for y1. Oops. And the right side was just a y equals 3. Oh my god. Good thing I looked. I almost typed it wrong again. It's hard to do it with my stylus on my laptop. Alright, radical x plus 3, y equals 3. Hit graph. And I should see an intersection at x equals 1. And it sure looks like it. If I go to my table, there it is with the repeated y value, which means the coordinate 1, 3 is an intersection, and that checks. So that concludes our Unit 3 review. Hope this helped.